Hi, in this video we're going to take a look at the January 2015 Higher Paper 1 question 8, and here's the actual question now. It starts off looking a bit kind of tricky because we've got a complicated looking triangle here. We're told that ABC is a triangle, as we can see, and the point D lies in AC. Now notice that it's a right angle here. According to the rule for angles in a straight line, that means that this must also be a right angle here. The angle ADB has to be a right angle, and we're told the lengths of various parts of it. We're asked to calculate the length of AD along here now, and we're also supposed to give the answer to C significant figures, which is important. We'll see that later on in the question. So we're going to be using Pythagoras theorem here because we've got two sides and we're trying to work out the third one. Now the important thing when using Pythagoras is to make sure that you identify which side in the triangle is the hypotenuse. The hypotenuse is always the c squared, and the other two that are added together are on the other side. Now where is the hypotenuse on this particular triangle? Well, it's right here. It's the longest line in the triangle, and it is also opposite the right angle. So we've identified that we already have the hypotenuse, so that's our C, that's what's going in here. 15 will go in place of a C. Now the big mistake that people make when they're using Pythagoras is they automatically just go for the A squared plus B squared, and you would get people doing 10 squared plus 15 squared here equal to C squared, assuming that this is C, the unknown value. But that's only applicable if we don't have this value here, and it's these two sides that we've got. When we're looking for the hypotenuse, what the equation that we're really using is A squared equals C squared minus B squared. So we're taking the C that we've got here and we're subtracting off the other side squared. Okay, so moving on, we put in the values. 15 squared minus 10 squared. That gives us 225 minus 100, which gives 125. We take the square root of that and we find that we get an answer of 11.18. Now, doing this on the calculator, you can see that we're going to use the square root button, which is this one here. And if we type in 125 and press it equals, we get 11.18. So it's this button here you use on the calculator to get square roots. Moving on, the second part of the question is going to involve using trigonometry. We're asked to work out the size of an angle, and we've got sides. So that automatically means that we're going to use trigonometry. Now, the trig equations are given in a booklet, a sheet at the start of your exam booklet. At the very beginning of your exam booklet, there is a sheet with all your equations on it, including the trig equations. And the equation that we're going to use here is the tan equation. Now, why is it the tan equation? Well, if you look at this, you'll see it's the opposite and the adjacent side to the angle that we've been given. We haven't been given the hypotenuse of this side. So the equation, the trig equation that uses the opposite and the adjacent is tan. Tan is equal to the opposite over the adjacent. So the tan of the angle we're looking for is equal to 10 over 12.5. So that's tan is equal to 0.8. When we do the calculation on the calculator, 10 divided by 12.5 will get 0.8. We then use the calculator to find the inverse of this. Now, to make this clear, on the calculator you're going to be using the buttons that give you the inverse of the trig functions. Now, to get the inverse trig functions, you've got to use the shift button, and in this case it's going to be shift tan that you use. Notice that you've got tan to the minus 1 in a kind of orangey colour above the button. Notice that the shift is also orangey, so whenever you press the shift, it means that the next button you press, you're not going to get what's in white on the button, you're going to get what's written above it in orange. And the same with this other button here, you'll see it's colour coded as well. However, we are pressing the shift button followed by the tan button, which would give us tan to the minus 1. That's what should appear on your screen. Then you put in your 0.8, then your equals, and you get your answer of 38.66 degrees, which is what has been looked for. Now, one step further than that, which I haven't shown you here, and I've done this quite deliberately because people will lose an entire mark out of the 3 at this point because they haven't read the question properly. If you look back at the question, it says calculate the size of the angle BCD and give your answer correct to 1 decimal place. I've got 2 decimal places here. What does that mean for me in terms of marking? Well, it means right away I've lost a mark out of the 3 marks that are there. I've lost 1/3 of the marks for this question simply by not truncating this to 1 decimal place. Now, converting this to 1 decimal place would give us an answer of 38.7 degrees. Bear that in mind when you're doing these sort of questions. When you are finished doing the question, you always look back at the question itself and ask yourself, have I answered the question that has been asked? And in this case, you can see quite clearly the answer was no. So you then look at what you need to do in order to answer the actual question that was asked. That's all for this particular video. Thank you for listening.